Before we go on to do what we have done for anomaly detection, just to set the context, why we are doing it, what use cases it is serving, what is the purpose of doing it, and whom it is going to serve. It's the anomaly detection that we are building, that we have built, is going to serve people like service owners, L2 operators, some of the personas it's going to serve. And the use cases it's going to serve is it will help people like L2 operators and identify any kind of anomalous behavior, any kind of change in pattern in the metric based on the previous historic behavior of that metric. It will be able to point out that anomaly, and for this, no thresholds need to be configured manually. It's a machine learning algorithm behind it would be taking care of baselining the thing. It would be dynamic in nature, and it will be able to find any spikes in memory, which has happened in the usage pattern of any VM. It could be virtual machines whose CPU is seeing a spike. It could be they would be able to configure that particular anomaly is probably persisting over a period of time. And similarly for network, if there is a spike in the network usage, there are more outbound API calls probably happening, and the workload is increasing. It's going to happen across API, application, infrastructure, and network. Uh, Say for service owners, if they are seeing any spike in login, a sudden spike in login, number of logins that's happening, they might want to take an appropriate uh, measure to ensure that the high availability is there for the workload that they are responsible for. So it's based on the historic data of the metric, on the time series data of metric. It will be able to predict, okay, if it will be able to identify, it will be able to identify a usage pattern, and based on that, it will be able to identify the anomalous behavior. Now, anomaly detection has been there for some time. We had that in form of DSP. Uh, anom- and there we have revamped this completely, and there were some focus areas for improvement based on the feedback that we have received. These are the three focus areas: performance, scaling, and alarm noise. So all the work that has been done to ensure that there is good performance. The performance of the anomaly detection increases. We are able to do it well, and both quantitatively and qualitatively. The scale, the amount of anomalies we can identify, an amount of metric data that we can process for anomaly detection can scale, and the alarm noise is also reduced. Now, to do this in the next gen anomaly detection, to achieve this, what's new that has come in? We have a better performing algorithm. We have introduced T-Digest here for anomaly detection. We have introduced some knobs in place which can help configure, set some configurations for better configurability around the algorithm, better configurability around the alarms, so that we can help reduce the noise. Uh, we are also looking into collecting and factoring user feedback in it. And most importantly, we have introduced metric group configuration, which ensures that not every metric is getting processed for anomaly detection. Not every metric is actually usable, or not every metric needs to be processed for anomaly detection. So user will have an option, a user interface, where they will be able to go and configure for the set of metrics or a group of metrics they want anomaly detection to be enabled, right? So this would make sure that people are, or the users are able to do anomaly detection over the exact set of metrics that they think it makes sense. And all this, what is coming new, there has been an improvement that have been achieved. So there's a 4x improvement in 4x improvement in the performance based on what the resources that we were needing. We are able to scale up and scale out So this algorithm and the architecture behind it that has been implemented, which Guru will be talking about in detail, uh, that the scale up, it helps in scaling up and scaling out. It gives the flexibility to do so. So 500K per minute of metrics being processed per pod. So if you just increase the number of pods, you will be able to scale out. You will be able to, there's no limitation from the architecture or algorithm standpoint anymore that we could uh, process only a certain number of metrics anymore. So we can go to any extent. And last but not the least is the configurations that we have introduced, which will also help in alarm noise reduction, along with a better performing algorithm, the metric group configuration, and also the alarm configuration that we have introduced. It will help in significantly reduce the alarm noise. This is how the metric group configuration would look like. This is where you will be able to create metric groups using filters for different products, source products like APM for NetOps, for CAPM, for UIM, etc. And you will be able to uh, enable anomaly detection, turn on or off the anomaly detection for it. These anomalies that are going to come up will be visible in say for physical memory that you're seeing. It will be visible in performance analytics, and there will be alarms for it that will be triggered and will be can be seen in alarm analytics. These are some numbers, preliminary numbers. This is without the alarm configuration that the algorithm itself is able to reduce the number of alarms or the alarm noise by almost 3 times. Uh, this is in comparison to DSP versus the NextGen, the new anomaly detection algorithm that has been implemented. This is where the alarm configuration. So part of the metric group, you will be able to configure alarm and do some configurations around where what would be considered as anomaly and when do you want to see an alarm for it. Now, road ahead, what are we planning next for anomaly detection? These are few things, not necessarily in the order of priority, but these are few consideration things which are under consideration for the next PI for us to work on. User feedback, algorithm tuning based on the user feedback so that we can just complete the loop, the algorithm kind of the last mile delivery of the algorithm in terms of for a particular tenant, for a particular set of users. That improves based on the learning itself, based on the feedback that comes from the user. So we have to first capture their feedback and then uh, loop back the feedback into the algorithm so that it performs based on it. Uh, Introduction of business lifecycle configuration for anomaly detection. That's one other thing which we are considering. That would definitely help in uh, better performing algorithm and also reduction in the alarm noise. Last but not the least is bringing in service context. So today it's all around the source applications, the source products that we are allowing users to create metric groups or create metric configurations and then be able to enable anomalies over it. We are looking forward to introduce service context in it where users can come in and be able to configure metrics, metric groups based on this service context. With this, I would I would just do a short demo of what I've just spoken about. This is the settings in operational intelligence, a familiar screen. If you have seen, this is a new screen where this is a new UI that has been uh, introduced. It shows 8 monitoring groups. You can just go ahead and say configure. This page would list all the metric groups that have been configured. It also shows the number of metrics for which anomaly detection has been enabled. It shows 233 out of 50K. So for now, we have just set a clamp size of 50K, which can be changed. Uh, and this will give you the source products on which these metric groups have been created, and the anomaly detection, whether it's enabled or disabled for it, and who has created these metric groups. Now let us take if you want to create one, just click on this create metric group, choose the source product. uh, Say if you want to uh, do anything around CPU, just filter the CPU metrics out, and you will be able to create a metric group for it. Right, and this will help you create a metric group. Now, for say same for UI and CPU users, the metric group already exists. If you want to edit, you will be able to go in and edit this. It already has a filter in place, and you will be able to configure the alarms here. This is where you can enable, disable, configure the anomaly detection, anomaly alarms. You will be able to use system settings, the default settings, or just uncheck it and go ahead and configure it. It will allow you whether the alarm, when anomaly is above the threshold, the single band which comes in, and the or below the threshold, which is identified, the threshold which is identified by the algorithm itself. You may choose to have alarms for both. It also gives you an option of alarm if anomaly is. So whether it is count over threshold or time over threshold, uh, and how many alarms do you think would be necessary when you would consider this an anomaly, and when you should you would need an alarm for it. So example for CPU usage, right? If it is crossing the threshold, if it is spiking continuously, if the anomalous behavior is consistent, if it is happening like 6 times in over 10 times, 10 different occurrences, then I would like to have an alarm for it. You can also configure alarm message. These are some of the variables that you can use, like metric name, uh, count over threshold, times, host, etc. And also configure the alarm policy. It will show you the notification channels which are linked. And once you are done, you just need to save this. This would save your alarm configuration. And sorry, and all the alarms that you would see are going to come in the alarm analytics, where you can go to all alarms, and then you can look for alarm type, anomaly, add, and you will be able to see all the anomaly alarms which are there. So this is one of it, and you will be able to open tickets, assign it to owners, etc. And yeah, and you can complete the life cycle. It will show you the usage affected metric, the anomalies that have occurred, and impacted services around it, topology, and any annotations which are there.
In this section, we'll be probably talking about the architecture overview. Yeah, just to touch upon like some information about like metric configuration. Metric configuration is basically like grouping a set of metrics. So as of today, we have an option to like work directly on either metric source or metric attributes, right? Here we will have multiple options to say like whether it contains CPU or more of a regex patterns if we want to pass, which will help us to just group the set of metrics. Primarily, it's just like a something similar to what we have like more of like a regex pattern to say like I want to see all the CPU metrics or GC metrics across all my sources, right? That is one thing possible. And as of today, that is like the primary filter that applies is the product. So out of the box, it will be like primarily like APM, CAPM, UIM, and based on the custom products also, we will identify and show, for example, if there are any third party like integration that has happened, that will also be listed. And then we can actually go towards like filtering based on source and attribute name, right? And it also helps us to like as we can actually go ahead and enable disable anomaly detection for that particular group. And then also on top, once the raw anomalies flow into the system, anomaly alarm configuration is basically like just an add-on on top of the like anomaly detection raw anomalies to go out and like probably like merge or compress all the alarms anomalies into a single alarm. If we are having 5 out of 8 occurrences, like if in the 8 monitoring time intervals, if we see an anomaly for 5 continuous like or 5 intervals out of those 8 intervals, then go ahead and like create an alarm for us. So this helps in even like noise reduction. Instead of like creating 8 anomalies, we can end up just having like one alarm that will be visible. And as of today, there are like clamps that are available per group. We say like maximum of 5K metrics that are allowed, and at the tenant level overall at like 50K to start with. So based on our like observations and then like sizing, we'll go over and like keep like increasing the scope or increasing the limits based on it. But as of today, it stands at like these limits. The reason why we actually have this is like during creation time, we might actually have like the metrics that are flowing into the system might be relatively less. So we might go ahead and enable the anomaly detection, but over time it might actually go ahead and increase, right? So first, for example, like we'll end up showing the list of matching metrics, but it might there is a background job which actually calculates the metric, and then like once we know the actual metrics that are getting matched, then we will allow them to enable or disable, right? This is one step where we want to allow the user to continue with the flow, and then like once we really identify the overall matching metrics for that regex, for by mistake if someone ends up like filtering all the metrics, it might be like millions of metrics, so we might have to go calculate and let know like this regex is matching this many metrics. So it's more of a background task, and then that will be automatically like updated in the UI saying how many metrics are getting matched per group. And once we configure during runtime, there is another possibility that we might end up having more metrics coming into the system. So we have a like a similar way, like more of a background job, which will constantly evaluate the number of metrics matching per group. And if we identify if some of them started like pushing more metrics, and if it goes beyond a clamp, we also have a flow of like notifying the users saying like there is a breach or increase in the number of metrics as such, and then like ask the user to accordingly take some action around it, saying like if it is going beyond the clamp that we support per tenant, if it goes beyond it, we actually like create an internal alarm that will be visible in alarm analytics. The user can go ahead and like act on it. If it is not taken care with the configured time, let's say like 12 hours or 24 hours, so we will automatically have an option to go and then like disable few groups to make sure like if the clamp is 50K and the current evaluation ended up at 70K, we will try to identify the groups which are like close to the 20K and then make sure like the remaining still are enabled, but we'll automatically go like disable those groups and then update the alarm as well, saying which of the groups that are modified, so that the user can always come back and then adjust to make sure like the resources are like within the limits. So this is purely from the metric configuration side. I'll move to anomaly detection. So here, anomaly detection or the new algorithm. Previously, like if like with respect to DSP, it was always more of a polling operation where we go to NAS, query the data, and then start processing. Whereas with this, like a new anomaly detection, we have more of a subscription pattern where like whenever the metric is there available in NAS, it will be automatically forwarded to Kafka, and we subscribe to that and then process. So that way, the overhead on the actual data platform services, which is NAS and metadata, is also reduced, and we are also like processing as and when the data receives. So this is like implementing the new metric calculator pipeline. And few information about the algorithm itself. So we have like basically like if we say something like a learning phase, we cannot actually start immediately like pushing data or create anomalies as and when we see the data. So based on our analysis, we identified like at least 500 data points is a good amount of set for us to know that okay, we have enough data points to start predicting or start like creating anomalies out of it. So during the initial phase, we will have like using a single model, we will actually accumulate all the data that we see. That is roughly close to a week, depending upon how continuous the data points are. And then we actually start having like more of extensive models per hour. So our models are like basically at hour of the week. So for every hour in the week, we will end up creating a model, and based on subsequent like data that we receive, we will end up and compare against this model to create anomalies. And the same thing holds good for anomalies as well, like how many data points that we look before start creating anomalies for it. And one more change, if we are aware of like the DSP one, is DSP used to have like 3 bands, which is basically common, probable, and then rare bands. With the new algorithm, we will only stick with like rare bands alone. And one more thing is as such, like once we create a group, right? There might be few metrics inside that group which may not really fit in. For example, like we say like give me all GC metrics, and then like it might be working out for most of the cases or most of the instances, but for few JVMs or few of those processes, it might be more like a sawtooth. It will increase, decrease, it will continuously, and it may not be a right fit for those cases. In such scenarios, the user has an option to say explicitly go to the individual metric and then say like, okay, we can go ahead and like stop processing anomaly detection for a specific metric out of the group. So rest of the metrics in the group will still continue to be processed, but only those metrics where the user feels like it may not be like a right candidate for anomaly detection, they can have an option to go ahead and like disable those metrics for anomaly detection. And based on our analysis, what we observed is like with the algorithm, it may not be a right fit for monotonically increasing metrics, because it always compares the past data and then start predicting saying like what will be the right set of values that we have seen. So in general, if we are having metrics like, for example, like wall clock time or uptime, which is always going to be increasing or decreasing in some form or other form, those metrics may not be a right fit for this algorithm itself. So it is recommended not to use those or metrics or configure those metrics for anomaly detection, right? And next part, like these are mostly on the configuration and algorithm itself. And the next one is the one that we talked about, like anomaly alarm configuration helps to actually suppress the alarms also. For example, the raw anomalies might be like many depending upon the data points, but we can as well have a like a more of a configuration to say how many anomalies do I see, should I see, or should I, what is my observation window before going ahead and notifying anyone to take any actions around it. So that is also part of anomaly detection. And over time, we also have, like, for example, if we disable some of them, or if we disable the metrics, the anomalies might still hang around. So we also have a background job which can go ahead and close any of the stale alarms that are available in the system based on the group configuration. For example, for a particular group, if we say like 3 hours is my observation window, so exactly after 3 hours, maybe the next schedule when it happens after 30 minutes, it will go ahead and identify if there are any open alarms which are more than 3 hours and no updates or any other things have happened beyond the 3 hours. It will automatically try to go and close, because there is no other like continuous observation that has been like identified for those.